ask questions, maybe if I'm not making sense here or something. Hey everyone, so it says graph the following transformations. This is always how we graph it. These three steps. Every single time, these three steps. So it says first, list out the parent function's xy points. You're going to know what the parent function looks like if you know the parent function's xy points. So for example, all functions have a parent function. With this one, wouldn't it be x squared, everyone? Yeah. So you'd say my parent function is f of x is equal to x squared. Now we're going to list out these xy points, and then we're going to perform the transformation to those xy points based on what we see happening with this transformation here. So look, xy, let's create some xy points. Now think about how functions work. How do we get xy points? Plug in stuff and we get something out, correct? Yeah. So let's plug in any xy points. Now with a squared, they're all going to be whole numbers. I like to pick numbers that come out nicely. So with this, anything I plug in will come out a whole number. Maybe like -3, -2, -1, 0, 1, 2, 3. The more points, the better, but you need around 4 or 5 points. At least 5 points, honestly. So now look, let's plug in. People are like, how do I get the y value? How do we get the y value, guys? Plug it in. Okay, -3 squared is 9. -2 squared is -1 squared. 0 squared 1. 0 squared 0. 1 squared 2 squared 4. 3 squared 9. Okay, here's my parent function points. We don't need to graph them because we're going to transform them. I could graph it though, couldn't I? So if I wanted to graph it on the slide to see what it looks like, it's a parabola. It looks something like this. Great. So now we're going to perform the transformation. So your second step, it says perform the transformation to each appropriate part. So in words, describe the transformation. Stretch of 2, correct? Stretch 2. Reflection over the x-axis. Then we have a right 1. And then a up 7. Now you do have to know which part this affects. So if you think about it, if we have xy points and we shift up 7, wouldn't that just take the y values and add 7? Yes. Yeah, it's a y shift. Shifts left and right are to your x. If you're going right 1, you're starting with xy points right here, and we're just shifting right 1. That would change your x values. Everybody understand? Now here's where we have to think a little bit. This is a vertical stretch. A vertical stretch is to your y values. You're stretching out only your y values by 2. And then right here, a reflection over the x-axis. If you have a point up here, and you're reflecting it over the x-axis, that will change your y values. So we're going to times all of our y values by -1, and then we're going to times them by 2. Because that's a y shift. A vertical stretch is a y thing. So why don't we just times all of our y values by -2, everybody? You guys see why that would make sense? Now, should we times first or add 7 first? Well, order of operations matter. Multiplication comes before addition. So we're going to times before we add anything, always. So you'd say, okay, I need to take my y values and I'm going to times them by -2, since that's a y shift and a y shift. Then after that, we're going to go up 7. So after we times by -2, we'll then add 7. Then we're going to right 1. So to all of our x values, we're going to add 1 to them, since we're going to right 1. So now what we can do is write down our new xy points. This is how you have to do it. Yeah, there's other ways to do it. This is how we're looking at transformations. So now say, what are my new xy points? -3 plus 1 is -2. -2 plus 1 is -1. -1 plus 1 is 0. We're just writing down our new xy points. Check, check, check. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. And that's enough points. I'm not going to even graph that one because that's just too many points to write for me. Now, 9 times -2 is -18 plus 7. Okay? There's the next y point. We're just plotting points after this. 4 times -2 is -8. -8 plus 7 is 0. No, it's actually 1. 1 times -2 is -2 plus 7 is 5. Okay? 0 times -2 is 0 plus 7 is 7. And then look, we already have done 1. 1 was 5, wasn't it? And then we've already done 4. 4 was -1. So look, now all you have to do is plot points. So it's going to be that same shape. It's still going to be a quadratic. It's just now had all these transformations. So -2, -11. Okay, that's off my graph. Negative 1, negative 1. Over 0 up 5. Over 1 up 7. Over 2 up 5. Then over 3 down 1. We know it's a parabola, so it makes sense. It's looking like a U. I would draw a nice, pretty graph. It's got to be nice and pretty with arrows and everything. Pretty easy though, right? Yes. When we reflect over the x-axis, that will change our y values only. Oh, okay. Which one's negative 1? Did you figure it out? Okay, awesome. Okay, awesome. Okay, let's look at another one. For example, let's say you're just given a random function like this. It's just a random picture of a graph. It all works the same way. So it says take the function, times it by 2, plus 3, so it'll be left 3, down 2. So what are my parent function points? This is the parent function, so you would just write down. Well, my parent function points look like this, x, y. So that would be over negative. Let's just pick some points on here. Like that point, and that point would allow me to recreate this graph. So negative 4 up 2. Then we have a over 1 up 2. Then we have an over 3 up 4. These are the parent function points. Now let's perform the transformation. So we would say, okay, we're stretching by 2. Now a stretch is a vertical stretch. That's a y value shift. So we're going to times by 2. Then after that, we're going down 2. So then after that, we'll subtract 2 from that. Our shift is left 3 units. So we'll take our x, y's and subtract 3 from them. So now I'm writing down my new x, y points. Negative 4 minus 3 is negative 7. 1 minus 3 is 3 minus 3 is 0. 2 times 2 is 4. 4 minus 2. Then we've already done 2, so we get another 2. Now 4 times 2 is 8. 8 minus 2 is 6. There's my new point. It's going to look like that same graph. It's just been transformed. So I'm going negative 7 up 2 units. Perfect. Over negative 2 up 2 units. Great. That point became that point. That point became that point. And then over 0 up 6. Ding. And now I'm graphing it. Easy stuff though, right? Same thing. Over and over again. Okay, so go to your homework. And let's look at 23. Isn't this number 23 on the homework? Maybe it's on the review.
You're right.
Okay, cool. Okay, so this is how we'd start out. We'd say, well, what would the parent function be? F of x is equal to x cubed. Now what we're going to do is pick some x, y points, everyone. Now think about it. Anything cubed will be a whole number, right? So we can pick any points, maybe negative 2, negative 1, 0, 1, 2. If that's not enough points for you to graph it, then go back and plug in more, like put a 3 in there as well, or whatever. Now plug it into your parent function. Negative 2 to the third power is negative 8, isn't it? Negative 1 to the third is negative 1. 0 to the third is 0. 1 to the third is 1. 2 to the third is 8. 3 to the third is 27. So I'm probably not going to graph that one because it's pretty dang big. Okay. But you're getting my point here. We can use any points we really want for this one. Now let's perform our transformation. Now careful, this one tricks people. Here's why. This is a negative inside our parentheses here. That's a reflection over the reflection over the y-axis. Now we have to be careful because what is considered not simplified? If you can recall, a negative in front is not considered simplified. So we're going to factor it out. Now I don't mean out, it can't come out, but we can factor it out of each term. We need to. So this is negative 1, parentheses, divide by negative 1, divide by negative 1. That would leave me with x minus 5 cubed. You guys see? So now it's actually a shift of what? Right? 5. Right here, if you look at it, you would have said left 5. But because this one has a negative in front and it's not considered simplified, we have to factor it out. So our two transformations are a reflection over the y-axis and then a right 5 units. Now guys, if you reflect something over a y-axis, look, here's the point. If I reflected over the y-axis, that would change your x's to be opposite. So in this one, we're going to times all of our x values by -1. Yes.
I'm sorry. I went ahead in the homework.
Yeah.
Because I wasn't here, so I.
Okay. Yeah, you didn't know.
So I did number 5 on the very last page. And I'm seeing it now with new eyes and seeing this.
Yeah.
And it's not a function. It says it's a function of f of x because it has two. It has twice the input with 3.
So it just means you take this, yeah. So it just means take this line and transform it.
Oh,
take this, whatever. It's zero. It's technically not possible. Yeah. Okay, so everyone, that's a valid question. So everyone, we're reflecting over the y-axis, aren't we? So we're going to times all of our x values by -1, and then aren't we going right 5 units? Isn't that a shift left and right? That's an x shift. So then we'll add 5. That did not change our y values. So let's write down our new x, y points here. Our y's are the same, aren't they? But our x's will now become, I'm going to write them just right here in front. -2 times -1 is 2. 2 plus 5 is 7. So we have 7, -8 is a point. 7, -8. Moving on. -1 times -1 is 1. Plus 5 is 6. So we have the point 6, -1 on our graph. 0 times -1 is 0. Plus 5 is 5. 5, 0. So you would be able to just plot these points. 1 times -1 is -1. Plus 5 is 4. So we have the point 4, 1. And so on. 2 times -1 is -2. Plus 5 is 3. 3, 8. And then 3 times -1 is -3. Plus 5. 227. Okay, cool. So graph those points. Ready, go. Plot them real quick. I want to make sure we're good with that. Do we see how to do it though? And like, let's say you're like, does that even look like the parent function? Plot the parent function points. If we plot the parent function points, it looks like this. Doesn't that look like the same graph, just transformed, everyone? Yeah. How did I know how to plot the parent function points? These were the parent function points. If I graph it, it looks like this. So it does look good to me. Okay, awesome. Okay, so just making sure here. What would my transformation be? Because this will trick people on the test. What is the transformation right here? Reflection over the y-axis. Careful though, what would this shift be? So remember, you pull out the -1, not out of the radical, but then it would be x minus 4 like this, minus 3. So this one would be reflection over the y-axis, right 4, and then down 3. Don't get tricked by that. There's a difference though, so this one we would times, since it's a reflection over y, we times our x values. Times your x values by -1. But right here, this is a reflection over the x, isn't it? Yeah. This one is left 4, and this one is down 3. So over x would be times your y values by a -1. Okay, I think we get it. Okay, awesome. So if on the test, okay, I think we actually get the picture here, but I just want to make sure because this one can be confusing. So it says reflection over the y-axis, write 1 down 3. How would we write the equation? Negative x plus 1, we're saying, cube minus 3. Now careful, check. If we did that, then that would be -1 factored out x minus 1 and then cubed minus 3. Now check, did you do it right? Reflection over the y-axis, check. Right 1, check. Down 3, check. You guys see how that works? We did it right. Awesome.
Can you write it either way?
Yep, I would accept either. Okay, if I said to you graph this one, this is number 1 on 1-10. Let's figure out how to do this one together, because this one can be a little bit harder for people to see what to do. So you'd say, okay, so f of x equals the cube root of x is my parent function. Now I need to find some x, y points. Now guys, pick some things for the parent function that are whole numbers. Like if I plug in 0, I get 0. That's great. If I plug in 1, what's the cube root of 1? 1. If I cube root -1, I get -1. Cube root of 2 is a decimal. I don't want to pick that one. Cube root of 3, 4, 5, 6, 7, 8. Cube root of 8. 2. So I'll go with, I'm picking smart points. Like they can be any points, but I don't want to do decimals as much. I mean, in my transformation, if I have to do decimals, that's fine. I don't want to start out with decimals. Cube root of 8 is 2, so then negative 8 is negative 2. That's probably enough points. 1, 2, 3, 4, 5 is probably good. Now we're going to say, okay, reflection over x. Okay, over x, then we're going to go right 2, up 3. Now think about it, reflecting over x would affect your y values. So you're going to times all your y values by negative 1, then you're going to add 3, because they're going up 3 after that. Times by negative 1 plus 3, times by negative 1 plus 3, times by negative 1 plus 3, and so on. And then right here, we're going to go right 2, so we're literally going to add 2. Add 2, add 2, add 2, add 2. So write down our new xy points. And go. Ready, go. Everybody go.
Wait, wouldn't it also be a square root of 3?
That's a cube root. Valid question. I have xy points that I'm graphing. What the? Did you get these same xy points? Or did I make an error somewhere? Okay, cool. Just making sure. See, this is on the test exactly what I need to see, and I'd even be able to just check your xy points with my xy points, you know? Right here, and then if you're good, we're good. Drawing your arrows, it looks something like that, doesn't it? Now let's say you're like, well, what the heck does that graph look like? Go plot the parent function points, and then you could know what the graph originally looked like somewhere up on the side. You can say, oh, it actually does look like the parent function. Because you guys, a cube root function looks like this. So it does look right. Does that make sense, everyone? Gotta kind of check your stuff. Okay, awesome. Now, I also have people not understanding. Let's say you're desperate to know if you're right. Couldn't you literally just go, like, you'd need to do it this way, but let's say you're like, did I do it right? Go make an XY chart and literally just start plugging things in, directly in. 0, minus 2. Do you see what I'm saying? You plug things directly in. They're just, if we do it this way, it's just going to be harder to find pretty points. But you can always check. You can say, I'm going to plug in negative 6 right here and see if I really do get out 5. I'm going to plug in 1 and see if I really do get out 4, just to check your points. So let's think smartly. Let's think advancedly. We got this. Okay, awesome. Okay, looking at, I think, number 2. Just tell me how you start it, and then I'll let you keep going by yourself. F of x is equal to what? X cubed, you plot some parent function points. Like negative 2, negative 1, 0, 1, and 2. Because all of those will be whole numbers. Negative 8, negative 1, 0, 1, 8. Then you're just going to perform the transformations and graph the function. It's the same for all functions. Do we understand how to do it? Okay, so everyone work on this one right now. Make sure you're good. Now, yes, our answers are going to come out decimals in this one. That's okay. We can plot decimals. Yeah. Because it's the same function, just no shifts. So it'd have to be x cubed. Okay, gotcha. looks like, then plot some more points. Like, if you've done this with this many points, then you're like, what's a point over here? Literally just say, I'm going to plug in 2, and then plug it directly into the function. You guys see what I'm saying? If you've done most of them with transformations, you can kind of plot more points by plugging them directly in. You get what I'm saying by that? Or no? Okay, cool. So then it's module 7, right? Yep, so then I'm like, oh, okay, great. I am looking good. Did I even graph this right? Well, I better plot the parent function and see. If I plot the parent function, it looks like that. You know what? It's looking good to me. Number 3 is like kind of a trick question we don't see very often. Here's why. Usually this is what we see. We usually see it written like this. 1/2 x to the 4th minus 2. What's different here? 1/2 is also raised to the 4th power. So how do we raise, what's 1/2 raised to the 4th power? 1/16. So this is equivalent to 1/16 x to the 4th minus 2. Do you agree? So now we'd say a stretch or compression. So stretch or compression. So stretch of 1/16 and then down 2 units. So you have your parent functions x, y points, which the parent function for this one would be x to the 4th. So you're plugging in -2, -1, 0, 1, and 2, 16, 1, 0, 1, 16. So now are we going to times all of our y values by 1/16? Since it's a vertical stretch or compression, right? We always stretch and compress our y values. And then after that, we'll subtract 2. So our x values won't change. Yes, it's going to be decimals. That's okay for plotting the new function. Now, once again, if you're like, what does x to the 4th normally look like? Plot the original parent function's points. So 0, 0 over 1 up 1 over -1 up 1 over 2 up 16 over 16. It looks like this, kind of like a skiwampus parabola. So it's going to be similar, just transform. So write down your new x, y points, whatever those are. So your new x, y points on this one would have been -2, -1, -1, -1.9-ish. 0, -2, 1, -1.9, and then over 2, -1. And then if you don't have enough points to graph, put some more in. Plug in a 3. Right here. You guys see what I'm saying? You guys, look at number 4. F of x is equal to root x would be our parent function. Now look, I have people doing some really odd things first hour. They're saying that square root of -1 is -1. Square root of -1 is, square root of -1 is I. We don't even have i's. So we would not graph -1. Where would we start? 0. Square root of 2 is a decimal, so I'm not going to put that one. Square root of 3 is a decimal. Square root of 4, that's fine. 5, 6, 7, 8, 9. Square root of 9 is a good one. 10, 11, 12, 13, 14, 15, 16, and 4. Great. There's some great points to use. Now perform the transformation very carefully. So finish that one off. thought it'd be continuing, so, and then they like, but did it start continuing? No. What did the original function look like? Started at 0, 0 and went that way. It didn't continue down that way, did it? So that point, guys, became that point. So it's not going to go past that. So kind of put 2 and 2 together of what point became what point. From this point became this point, and so on.